Hey, in this class we're going to go over the October 2023 Math SAT for the non-calculator section. So yeah, let's get started. The first question says, the graph models the radioactive decay of sodium-24 in a sample over time. According to the graph, so looking at this graph over here, at 5 hours, so looking at the hours, we're going to look at 5 hours because that's what they said here. Which of the following is closest to the mass? So if you look at the mass, this is the y-axis, the mass. And then it wants it in milligrams, which we already have. So always check the units because that's pretty important. But yeah, so we already have the units that they're asking for, so we don't really care about that much. And then, so yeah, it's asking, so at 5 hours, what is the mass of sodium-24? It is 40 milligrams. So that's a very, very easy question. Question number 2, x plus 3 in absolute value is equal to 6. What is the positive solution to the given equation? So there's two ways to approach this. First way is literally, since this is a multiple choice question, plug in each number into x and see if the answer makes sense. So for example, if you plug in 2 plus 3 equals 5. So 2 is wrong. If you plug in 3 plus 3 equals 6. So B is correct. And then for C, 9 plus 3 is equal to 12. So that's wrong. And for D, 18 plus 3 is 21. So that's wrong once again. So that's one way of doing the question. And we found out the answer in like 10 seconds. Okay. The other way of doing it is actually solving it. So we'd have two solutions. You'd have x plus 3 is equal to 6, and then x plus 3 is equal to negative 6. Two solutions because this is an absolute value. We don't know if the answer that comes out of it is positive or negative. So yeah, and then solving this, you get x is equal to 6 minus 3, which in this case is equal to 3. That's one solution. The other solution is x is equal to negative 6 minus 3, which is equal to negative 9. And since the question is asking for a positive solution, it is equal to 3. So that's both ways of doing it. Question number 3, y is equal to 4 minus x. What is the graph of the equation? That 4 minus x. So there's one choice here, and then there are, I think, 3. Yeah, so the other 3 choices or options are on this page. But first, you have to look at the question and kind of change this to a format that we've seen before. Instead of y is equal to 4 minus x, we can rewrite it in terms of y is equal to mx plus b, which in this case would look like y is equal to negative x plus 4. All I did was I took the negative x, I put it first, and then the positive 4, I put it after that. And we are used to seeing it like this, so this will make it easier for ourselves. Okay, so what I'm looking for is a y-intercept of 4. So this has it, which is correct. The y-intercept is correct on this graph, but the slope must be negative. In other words, it should be going down this way. So I know that A is wrong because the slope is going upwards. We need a negative slope and an intercept of 4. Over here we have an intercept of 4, that's correct. And we have it going down, so that is correct as well. So most probably the option that is correct is B. But let's also check the other two options just to make sure that we are correct. Over here, the y-intercept is negative 4. So this is wrong by default. And same with this one, the y-intercept is negative 4. So that's wrong by default. These are both wrong because the y-intercept is not 4. Okay, that's question number 3. Pretty easy. Question number 4, we have two equations. Y is equal to 7 minus 4x and 15x minus 4y is equal to 3. And then it says, what is the solution x comma y to the given system of equations? Okay, this one is pretty simple, but it might take a bit of time. So our first step is to try to get rid of some variable that is common between both. So either try to get rid of both y's, or try to get rid of both x's, or there's two different solutions for this question once again. The other solution would be to make them both in terms of y, and then equate them together, which I think is going to be easier since one of them is already in terms of y. So the other one, let's also make it in terms of y. We would get 15x minus 3 is equal to 4y, and then divide both sides by 4, kind of like this. You get that y is equal to 15x over 4 minus 3 over 4. Okay, pretty simple. Now, since we have that y is equal to something on both ends, let's equate both sides of the equation. We get that 7 minus 4x, which is equation number 1, is equal to equation number 2, which in this case is 15x over 4 minus 3 over 4. And that is how you find a point of intersection. You equate both equations and solve for x. So yeah, let's solve for x. First, I'm going to convert the equation to bring all the x's on this side and bring all the constants on this side. So first, I'm going to add 3 over 4 to both sides, plus 3 over 4, kind of like that. These will go away, and you would end up with 7.75, because 3 over 4 as a decimal is 0.75. is equal to, and then now let's add 4x to both sides. So plus 4x plus 4x, you get that 15 over 4 is equal to 7.5 divided by 2, which is equal to 3.75. So you get 3.75 plus 4, which is equal to 7.75x. Okay, so this is one way of doing it. You just bring all the x's to one side, and then bring everything else to the other side, and solve for x. So divide both sides by 7.75, kind of like so. And you end up with x is equal to 1. So we got that. So now we know by looking at our options that A and B both must be wrong. Because if x is equal to 1, we have C and D left. Okay, last question, or last part of the question, how do you figure out which is it C or D? So pretty simple, you plug in your answer of 1 into either of these equations. I'm going to put it into 1 because that just makes more sense and it's easier. So if x is equal to 1, y would be equal to 7 minus, instead of 4 times x, we know that x is now 1, so it would be 4 times 1, which is equal to 7 times 4, which is equal to 3. So if x is equal to 1, y is equal to 3, and this is our point, so I'm going to circle C, that's my right answer, and D is wrong. Okay, that's question number 4. Question number 5, here we have 2 equations again, or 2 inequalities actually. But yeah, I'm going to actually rewrite this on the next page because all the options are here. So y is less than or equal to 2x plus 3. And then the other one is y is greater than or equal to 0.5x minus 6. So y is greater than or equal to 0.5x minus 6. And yeah, those are both of our inequalities. And now we're looking for which of these options, makes more sense for both inequalities. You need to know this for inequalities, but if you have less than or equal to, imagine a graph with a line. Let's say this is the line of 2x plus 3. I'm going to draw it. It looks something, let's say like this. If y is less than or equal to 2x plus 3, we are looking at the region below the line because it is less than. If it was greater than, we would be looking at the region above the line. So in this case, we have a line that looks kind of like this. And since the sign is less than or equal to, we are looking at this region. So that's the first part. So which of these kind of drawings has a line that's going up, kind of like so, with something that's colored below it? If you look at both lines, we are going to have this one because the line over here, like we know, is the y-intercept is at 3. So you'd have the y-intercept here. I'm going to zoom in a bit over here. This would be the y-intercept. And this would be the actual line. And we are colored below it. For number A or part A, this is the line and we are colored above it. So this is wrong. For part C, this is the line and we are also colored above it because this would all be above it. So C is wrong. And for D, if you look at this line, we are colored below it. And if you're wondering why it's not colored below it throughout the entire region, it's because we also have to consider the other line. Okay, so far, B and D could be the right answers. One of them is the right answer. Okay, but that's what we got from the first inequality. The second inequality says that there's a line with a y-intercept of -6. So the -6 would be somewhere here. And you have a positive slope, which would look something like this. And we are looking at the region above it, because this is greater than or equal to. So you'd have this region like so, above that line. In other words, now if you look at B and D, which of these has the other line colored above it? I'm actually going to do this in green. But if you look at the other line, this line and this line, which of them is colored above it is going to be B. Because for D, it is colored below it, which is wrong. Okay, so B is the right answer for this one. Question 6. The given function f models the annual worldwide production of avocados in millions of metric tons t years after 2000. According to the function, by how many millions of metric tons does the annual worldwide production of avocados increase from 2010 to 2011? Okay, so I'm not even going to look at our options because this one's super easy. But if you are ever talking about the increase of a linear function, your answer is always going to be the slope. If it was decrease instead of increase, then you're looking for a negative slope. So let's say we had another function, f of t is equal to negative 0.17t plus 2.54. Since this is a negative, and if the question said decrease, your answer would also be 0.17. Okay, but once again, since I saw the word increase, I look at the slope because that's how much we increase each year, since t is the number of years. So if you increase that amount per year, that is your answer. So the answer is 0.17. So that was very, very simple. But once again, look at the slope, because that's how much you increase per year. Okay. Question number 7, which equation has no solution? Okay, so for all of these, you have to know two things. To have no solution means that something impossible should happen. So what I mean is this. Let's take the first one. Let's actually try to solve it. 4x plus 4 is equal to x plus 4. And I got 4x plus 4 by expanding this bracket. And this will give me 3x is equal to 0, x is equal to 0. Is there anything impossible that happened here? No. So this is a perfectly valid equation, and it has a solution. So A is not the right answer. Let's try B. So let's expand this again. You get 4x plus 4 is equal to x plus 1. Subtract x from both sides. You get that 3x is equal to, and then subtract 4 from both sides as well, is equal to negative 3. So x is equal to negative 1. Is there anything invalid about the solution? No, everything's possible, everything seems okay, so B is not the right answer. Okay, let's continue to move on. Let's expand this once again for part C, so 4x plus 4 is equal to 4x plus 4. You can subtract 4x from both sides, you get that 4 is equal to 4, and is this invalid? If I tell you, is 4 equal to 4, your answer should be yes, because there's nothing wrong about that statement. That means C is not the right answer as well, because there's nothing bad about this. So by the process of elimination, D must be the right answer, but let's also check it like we always do. So first I would once again, let me erase this actually. First you would expand the bracket, so you'd end up with 4x plus 4, like all the time, is equal to 4x. Okay, now if you subtract 4x from both sides, kind of like this goes away, and you would end up with 4 is equal to 0. Is this a valid statement? If I ask you, is 4 equal to 0? Your answer should be no, that is wrong. That means this equation has an invalid solution, therefore D is our right answer. Okay, that's question number 7. Question number 8, the function f is defined by this part over here. Which of the following is not an x-intercept of the graph y is equal to f of x in the xy plane? Okay, so if you are ever looking at x-intercepts, you are looking at the brackets in the function, and you're taking what makes the bracket a 0. So for the first bracket, how would you make this bracket equal to 0? Your answer would be if x is equal to 1, because 1 minus 1 is 0. So that's the first bracket. For the second bracket, what makes this bracket a 0? Your answer should be x is equal to negative 1. So that's also another possible solution, because if this is 0, the entire equation is a 0, which means that you have a y-intercept, or x-intercept, sorry. For the third bracket, what makes this bracket a 0? If you have x is equal to negative 2. So out of all of these, we have 1, negative 1, and negative 2. These are our possible values of x in this equation or function. That means if you look at these values over here, we have negative 2. I'm going to do this in red. We have negative 2, so A is not the right answer. We have negative 1, B is not the right answer. We have 1, C is not the right answer, but we are missing D, and therefore it is not an x-intercept, so D is the right answer. Pretty simple. Question number 9, which expression is equivalent to 16 to the power of half x? Okay, so first, for this question, you have to consider something that is very kind of tricky. But if you are multiplying 1/2 times x, what this is telling us is that this was at some point 16 to the power of 1/2 to the power of x. Once again, this is because we have our power to the power rule of exponents. So if you have this, you would usually multiply them and you would have half x. So we're kind of working backwards in this case. Okay. After that, pretty simple. If you have 16 to the power of 1/2, that is the exact same as saying I'm taking the square root of 16, because that's what the power of 1/2 means. And then I'm going to raise this to the power of x, because this does not go away, it stays there. Okay. Then you ask yourself, what is the square root of 16? Your answer should be 4. X stays there once again because we didn't do anything with it. So the answer from all of these is A, because that is what we got. Okay, so that's question number 9. Pretty simple so far. Question number 10. Trapezoid ABCD is similar to trapezoid PQRS. So by similar, you should already know this, but that just means that every angle is the same and every side length is different, but it's kind of like a scaled up or down version of the same picture. So for example, if I showed you a human, kind of like this, and then I took the exact same human and I stretched them diagonally to make some human that is just bigger, but the exact same person. This is going to be a similar human because there are the same angles, they're the same thing, same shape, but the size is different. So it's a similar trapezoid because of that. Okay, and then so the question is the length of each side of the trapezoid PQRS is 3 times the length of its corresponding side of trapezoid ABCD. So we have two trapezoids. I'm going to actually draw one in a very small kind of shape. And you have an area here, but then we increased each corresponding side to be 3 times bigger for PQRS. So I made this 3 times bigger. So you can kind of draw 2 more trapezoids kind of like so. Something like that. You have 3 more trapezoids. It's 1, 2, 3, 3 times bigger. And same thing for the height, because if the height was 1, it becomes 3 times bigger as well. So you can draw kind of something like this. So imagine these are perfect trapezoids and they are all similar with the exact same kind of dimensions. Okay, so now we have this number of trapezoids. The question is, what is the area in square meters of trapezoid PQRS? Basically, if trapezoid ABCD had an area of 6, what is the area of the bigger trapezoid? And you can imagine the bigger trapezoid being drawn on all 9 of these kind of square or points. And I drew it this way because I want to show you that if you increase the height and the width by 3 of each, you are increasing the total area by 9, because this became a 3 by 3 grid. So if you increase the width by 3, you're multiplying the area by 3. But since we also increase the height by 3, you're multiplying this by 3 again. So in theory, you're multiplying the actual area by 9. So multiply by 9. So if the area of the smaller one is equal to 6, 6 times 9 is equal to 54. So 54 must be the right answer because that's the factor that we increase the area by. We increase the actual area by 9 times. Okay, question number 11. Here we have the function f, which is defined by x plus 1 squared minus 9. And then it says in the xy plane, the graph of which of the following equations has no x-intercepts. So which of the following equations here have no x-intercepts? And if you notice, they all do something to f of x. So f of x in the previous page, I'm going to copy it down. That was equal to x plus 1 squared minus 9. So x plus 1 squared minus 9. And then, basically, what do we do to the f of x or the function so that the function no longer has an x-intercept? So first, you have to kind of imagine the function and see where the x-intercepts are right now. Okay, so if you draw the function, I'm going to do it in green. Right now, if you draw x plus 1 squared, you would have something along this line. Your x-intercept would be at -1. Okay, but then if you bring it down by -9, you would end up with something that looks like this at -1, and then it's at -9, because it used to be at 0, but we brought it down to -9. Okay, so that's pretty simple so far. I'm going to erase most of these lines to make it more visible. But yeah, this is what we have so far. So we are at -1, comma, -9. This is where our point is so far. And then, basically, how do you get rid of an x-intercept? So as long as, I'm going to draw this again, kind of like this, if this function is pointing upwards, it's a parabola that's pointing upwards, and if you always start the vertex kind of below or at the x-axis, so imagine this is kind of like a checkpoint. I'm going to do it in blue. Imagine this is a checkpoint, this blue line. If you do it on the blue line or below it, you always have an x-intercept. And that makes sense because your curve can be pointing upwards like this, or like this, or like this, and you would always have that x-intercept here, or here, or here, or here, or here. Basically because you can expand these lines. But yeah, so we are trying to make it so that this graph opens up. I'm going to erase this. But if the graph opened up above the blue line, let's say somewhere here, then there is no x-intercepts because the x-axis is here, and then this opens up, so it never goes down to touch the x-axis. That's our main goal of getting rid of an x-intercept. So how would you do that? Right now, if it's at -9, we need to go at least 9 up to be at the line, but if you go anything above 9, if you add anything more than 9, you are above the x-axis and you succeeded of removing all the x-intercepts. Okay, so our only option here is plus 11, because once again, if you go up by 9, you are at the x-axis, so you still have one x-intercept. If you go up anything else, you get rid of the x-intercept and you are done. So D must be the right answer. But yeah, so question number 12 now. There's a typo in this question. This should be negative 6y. Okay, but yeah, so I'm gonna rewrite this. So this is a y. Okay, but yeah, let's start. So here we have x squared minus 10x plus y squared minus 6y is equal to 30. So then the question says, in the xy plane, the graph of the given equation is a circle. What is the area of this circle? So first you have to know what the equation of a circle looks like on, let's say if you're trying to draw it on Desmos, for example. So first you would end up with x squared minus 10x plus y squared minus 6y is equal to 30. I just rewrote the question with the 6y just to make it a bit more clear what I'm doing right now. Okay, after that, the actual equation for any circle says that you should have x plus, or actually minus, some constant squared, and then plus x or y minus some other constant squared is equal to the radius squared. Okay, so let's take that into consideration now. How do you combine all the x's to be in one bracket and all the y's to be in another bracket? So this is a very common trick you've probably seen before, but you have to complete the square. How do you complete negative 10x? You have to add 25, because if you want 10x to be inside one bracket, so we want x minus a squared, we want this to be the format of all the x's. Okay, to do that, you have to make this and something else into the same bracket, so we would have x minus 5 squared. This is what happens if you add 25. You can complete the bracket, and I did that by finding out that you have to divide this by 2 to get the negative 5, but then you also have to square it, because if you square this, you multiply negative 5 times negative 5. And when you do that, you get 25, which is what we added here. So that's how I got the bracket. But if you add 25 to one side, you have to add it to the other side as well. So you have to add 25 to this side as well, like this. And then from here, it's pretty simple. Let's do the exact same thing for y. I'm going to erase these lines just to make it a bit more clear. So for y, we wanted the same thing, y minus b squared, in the format of one bracket. So how do you do that? You need to combine all these y's plus something else to fill in the bracket. And what is that something else? First, I divide the 6 by 2. You get 3, but then square the 3, because you would usually square over here. So first, I would get that y minus 3 squared is equal to whatever. So I combined everything that I wanted into the bracket. But once again, to find out how much you need to add to this side, you have to square that 3 that you added. So in theory, even though we only added 3 to the bracket, we actually added 9 to the entire equation on one side. So you have to add 9 to the entire equation on the other side as well. Kind of like that. And then all this is equal to 30. And once again, let's put the numbers that we added here. So plus 25 plus 9. Okay, so that is our equation of the circle. And now you can actually look and see what the radius is, because we have it here. Before, if you looked at this equation, it says that the radius square is 30, but this is wrong, because it's not in this format that we talked about in the beginning of only brackets. So if you make it only have brackets, this final term will only be the radius squared. Okay, so now what is 30 plus 25 plus 9? 30 plus 25 is 55. And then 55 plus 9 is 64. Okay, so r squared is equal to 64. And then one last step, we know that the area of the circle is equal to pi r squared. And in this case, r squared, we already know, is equal to 64. So the area is equal to pi times 64, or in other words, it is 64 pi. So this question was a tiny bit difficult, but you have to know how to convert from this format to the format of the equation of a circle. Okay, so that one was pretty difficult. But yeah, question number 13 now. We have a division of two polynomials. And then it says the given expression can be rewritten as a plus 20 over x plus 5, where a is a polynomial. And then it says which of the following represents a. This is a very common question as well. But the trick to this is to do some long division of polynomials. Pretty simple. So first you take x squared plus x, put it on the inside, so x squared plus x plus 0, because you always have to complete the polynomial. Since it's missing a constant, you add the 0, which does nothing, but it's only for looks. The look of the polynomial must be correct. Okay, and you're dividing this by x plus 5. So x plus 5 on the outside. Okay, and then you're basically long dividing now. So how many times does x plus 5 go into x squared plus x plus 0? Your answer should be x. So you write x on the top, and then you multiply this out. So x times x is x squared, and then x times 5 is 5x. So plus 5x, and then subtract. X squared minus x squared is 0, or 0x squared, I guess, but 0. And then x minus 5x is equal to negative 4x. So negative 4x. And then bring down the 0. Once again, this is nothing, but we're only doing this just to follow the usual and casual rules of dividing long polynomials. Okay, now how many times does x plus 5 go into negative 4x? Your answer should be negative 4, because you're always looking at the first term. So x times negative 4 is equal to negative 4x. But now, we know that, so once again, like I said, negative 4 times x is negative 4x, but then negative 4 times 5 is negative 20. So now we subtract everything, kind of like so. Negative 4x minus negative 4x is 0, but then 0 minus negative 20, I'm going to write it here, 0 minus negative 20. Both negative signs become positive. You have 0 plus 20, which is equal to 20. So this is plus 20. So the final answer is x plus 4 plus 20. I'm going to write it here actually on the bottom. So x minus 4 plus 20 over x plus 5, because you can think of this as a remainder. We didn't really divide it. We just kept it there. We left it. So now we can compare this to what we have in the question. We have the 20 over x plus 5, so that is correct. What is a? A is everything else, which in this case is x minus 4. So the answer is x minus 4, and we are done. Okay, question number 14. Here we have an equation. 1 over c is equal to 1 over d plus 1 over e plus 1 over f. And then the question says, an electric circuit contains 3 capacitors in a particular arrangement. The given equation relates the equivalent capacitance C of the arrangement to D, E, and F. So yeah, as we saw, and yeah, those are the capacitances of the individual capacitors. Okay, so a lot of engineering stuff that you do not need to know so far. The actual question is, which equation out of all of these correctly gives C in terms of D, E, and F? So yeah, like I said, everything before this part was engineering garbage that you do not need to know for this question. Okay, it's all there to confuse you and make it seem harder than it is, but all you have to do is rearrange the equation so that C is equal to something. Right now we have 1 over C is equal to something, not C. Okay, a very common mistake that I've seen a lot is that people might just say, okay, if you want C on top, why not just flip each fraction so that we have D over 1, E over 1, and F over 1, and then A would be a right answer. This is wrong, because this is not how math works. If you want to find out what this is, you have to have one fraction on either side of the equation first, so then you can flip it. So for example, if you had that 1 over c is equal to x over y, I don't know, any variables or any constants or whatever. X and y don't matter, this is just a demonstration. If you have this, since you have one fraction on this side and one fraction on this side, now you can flip it. This would be c over 1 is equal to y over x. Okay, so like I said, our main goal first is to have one fraction on either side of the equation. Okay, let's do that first. How do you combine all of these to be one fraction? Pretty simple, add them up. How do you add fractions with different denominators? Find a common denominator. Pretty simple. So what's the common denominator between D, E, and F? It has to be D, E, F. If you have any sort of variables, the common denominator is found by multiplying all the variables together. Okay, pretty simple so far. So if I rewrite this down, I'm going to say that this is equal to 1 over c. Actually, I'm going to rewrite the question by itself. So 1 over d plus 1 over e plus 1 over f. Okay, now, like I said, how do you make them all have the same denominator first? You find a common denominator, and how do you do that? You multiply d by e and f, because those are the other two variables. How do you get from e to def? You multiply by d and f, so multiply d, f. And how do you get from f to def? You multiply by d and e. So multiply this by d and e. And when I say multiply, I mean multiply the numerator and denominator, not just one of them. Okay, what would that give you? 1 over c is equal to ef, because you multiplied that by 1. So ef over def plus df over def plus de over def. Okay, once again, this df I got here because I multiplied by 1, and then this de I got here because I multiplied that by 1. Okay, now since we have the same denominator on all the fractions, we can actually add them up. If you add these up, you would get that 1 over c is equal to EF plus DF plus DE all over DEF. And now, since we have one fraction on either side of the fraction of the equation, you can actually flip them both. You get that c is equal to DEF over EF plus DF plus DE. Okay, pretty easy, and that's how you find the answer. So the answer must be D. And we are done. Okay, let's move on to the next question now. Question number 15. The cost of renting a bicycle is $8 for the first hour plus 4 for each additional hour. Which of the following functions gives the cost C in dollars of renting the bicycle for h hours, where h is a positive integer? Okay, so basically, find the function or equation so that this makes sense. Okay, so the cost of renting a bicycle for the first hour is $8. I'm going to write that the cost C is equal to 8 so far. But then it says you pay an additional $4 for each additional hour. So if h was a variable of hours, you would first multiply 4 times h to get the number of hours you would pay $4 for. But this is not the right answer because it says for each additional hour. The first hour was already paid for by $8. So instead of multiplying it by h, you would multiply it by h minus 1 because we are decreasing how many ever hours we have by 1. Let's say you, write it for 2 hours. You're going to pay 1 hour for $8, and then 2 minus 1 is 1, so you'd pay another hour for $4. Okay, that's how this works. And now, basically try to make this equation that we have here look like any of these ones over here. Okay, so first things first, I notice that there are no brackets, so I'm going to expand. I'm going to get that 8 plus 4h minus 4, and then combine the 8 and negative 4, you get that this is equal to 4h plus 4. And this is the cost in, dollars or whatever. Okay? And then which of these functions does it look like now? If you look at all these, it must look like D because we have 4h plus 4. So pretty simple if you know what you're doing. Okay. Question number 16. Which value of r is the solution to the given equation? This one is super easy. All you have to do is literally expand the bracket and find what r is. So you end up with 5r is equal to 3r plus 3 if you expand the bracket. Subtract 3r from both sides. You'd end up with 2r is equal to 3. Divide both sides by 2. You end up with r is equal to 3 over 2. And we are done. That is super easy and super simple. Okay, question number 17. Here we have this equation and it says, what is a positive solution to the given equation? Okay, this one is a tiny bit difficult because you have to do a bit of expanding and slide and divide, or basically factor the equation that you are going to get. Okay, there's a lot of ways to do that, but I'm going to use slide and divide if you guys know what that is. So first I'm going to expand this. Instead of 3x all squared, I'm going to get 9x squared, and then minus 4 times 3x is 12x, minus 12 is equal to 0. Once again, to find a positive solution or to find any solution of any quadratic equation, you have to factor it. So how do you factor this? I'm going to use slide and divide like I said. So slide the 9 with the 12, you end up with x squared minus 12x minus 108 is equal to 0. And then now you're looking for two numbers that are multiplied to get you negative 108, but added up to get you negative 12. So what two numbers are those? So once again, this requires a bit of thinking and there's no other way of finding this. But if you've done this before, you know that those two numbers are negative 18 and 6. Because if you multiply them, you get negative 108. If you add them, you get negative 12. Okay, so now I'm going to make my two brackets. I'm going to say the first one is x minus 18 and x plus 6. And then this is equal to 0. Once again, after you find your two numbers, you just put them both in a bracket alone with an x attached to them. And now, since this is called slide and divide, we multiply this by 9. So now you have to divide both of these numbers by 9. 18 divided by 9 is 2. So instead of 18 over here, I'm going to have a 2. And then over here, 6 divided by 9 is the same as 2 over 3. So I'm going to write 2 over 3. But if you have this 3 over here, it is the exact same as having 2 here and then bringing the 3 to be stuck with the x. So I had 2 over 3, but I brought the 3 up here instead. Okay, so same thing. And now, what are my two possible solutions for x? My first solution is equal to 2, because 2 minus 2 is 0. So 2 is my first solution. And then my other solution is negative 2 over 3. So negative 2 over 3 is my other solution. The question says, what is the positive solution? So my answer must be 2. So x is equal to 2 is my final answer. Pretty simple if you know what you're doing once again. Okay, line K is shown in the xy plane, and line J, which is not shown, is perpendicular to line K. What is the slope of line J? This is a very super common SAT question that you'll basically see on every SAT that you've ever tried in your life. Okay, first things first, I guess, is find the slope of this line, and if it's perpendicular to line K, that means you find the negative reciprocal of that slope. Okay, so let's do that together. What is the slope of this line first? I'm going to take 2 points. Let's say this point over here and this point over here. The first point is at negative 5, 0, and the second point is at 0, negative 2. Okay, now to find the slope, it's equal to rise over 1. So to find the rise, how much did you go up or down by? We went down by 2. So rise is negative 2. And the run, we went across by 5. So the run is 5. Okay, after that, what is the negative reciprocal of this slope over here? The negative reciprocal, first of all, you take the reciprocal, which means that you flip the fraction. So right now it's negative 2 over 5. It would become 5 over negative 2. And after that, make it negative. So if it's already negative, make it positive, and if it's positive, make it negative. Basically, change the sign on it. So this would become 5 over 2. And that is your slope for the perpendicular line. Once again, if it's perpendicular, find the slope that you already have and find the negative reciprocal, and that is it. That is your answer, and we are done. Question number 19. In the xy plane, the graph of y, which is given by this plus k, is, I guess, what we're looking at. And it says where k is a constant, has a y-intercept of 0, 2. What is the value of k? All right, so in this kind of equation or function or graph, we have a point that is known, 0, 2, and we're trying to find out what one of the unknowns is. So what you always have to do is plug in 0, 2. So first, our x value is 0 and our y value is a 2. So instead of x, I'm going to plug in 0. Instead of y, I'm going to plug in 2. So 2 is equal to negative 14 times 1/2 to the power of 0 plus k. But anything to the power of 0 is 1. So this is useless. It goes to 1. So 2 is equal to negative 14 plus k. Add 14 to both sides, kind of like so. You get that k is equal to 16. And you are done. Pretty simple, pretty easy, nothing fabulous. Everything you should already know. Okay, question number 20. Last question. It says the perimeter of a square inscribed in a circle is 30 inches. The radius of the circle is x root 2 inches. What is the value of x? Okay, this is a very common question as well. It says in a square inscribed in a circle. So what that would look like is you would have a circle. Inside of it is a square. That's what inscribed means. It just means that there is a square inside of a triangle. So actually, yeah, instead of inscribed, you can say inside of a triangle. A circle, not a triangle. So, and then it says the perimeter of that square is 30 inches. If the perimeter is 30 inches, and we know that a square has 4 sides, that means each of these sides is 30 over 4 inches. Okay, so this, I'm going to do it in green. This would be 30 over 4. Oops, let me go back to the page. But yeah, this would be 30 over 4. I'm going to redraw it. This would be 30 over 4 as well. This would be 30 over 4 as well. And then lastly, this would be 30 over 4 as well. They're all 30 over 4 because the perimeter is 4 times a side length of a square. Okay. After that, you are trying to find the radius of the circle. So let's kind of draw it and see what we get. Okay, so to get the radius, you have to find out, I'm going to do it in, let's say, green. You have to, from this is the center of the circle, you have to go to the corner of it and find the radius. This is the radius, this is the radius, this is the radius. But if you ask, okay, which one should I use? The answer should be the one that touches the square on its side length. Because we have something about the square. If you know anything about the square, you can get anything else about the square. And then since this is related to the square, you can find how much it actually is. Okay, so now, pretty simple. All you have to do is find out what the diagonal of the square is to then divide it by 2. Okay, so to find the diagonal of the square, first, if you know that these are equal, this is a special triangle that you should already know. So if these are equal, this is 30 over 4, and this is 30 over 4 as well. They are equal. This is a special triangle, like I said. That means this would be root 2 times 30 over 4. the special triangle, I'm going to do it on the side actually. It says that if you have a triangle with two equal side lengths, and this is 45 degrees, 45 degrees, and this is a 90-degree angle, then this would be x times root 2. Basically multiply whatever this side length is by root 2. Okay, so that would be our entire diagonal. This, what I just found, this number over here, is our entire diagonal, which is this over here. This entire thing is root 2 times 30 over 4. But we only want half of it because the radius isn't the entire thing. It's only this part over here, from the center to this part, only this part. So what I'm going to do is I'm going to take root 2 times 30 over 4 and then divide it by 2. Okay, now it's pretty simple. You have to find out how much this thing is. So you multiply root 2 by 30 over 4. Instead of dividing by 2, you multiply by 1 over 2. Basic multiplication of fractions. And then after that, you get root 2 over, I could simplify to make this easier. I'm going to make this a 15. I'm going to make this a 1. So this goes away now. You get root 2 times 15 over 4 is your radius. But then the question says, the radius is x times root 2. So in this case, we're not looking for the entire radius. We are looking for this part over here because we already have that root 2. So let me repeat that again. The radius is 15 over 4 times root 2, but it's also equal to x times root 2. So if 15 over 4 times root 2 is equal to x root 2, what is x? You would divide both sides by root 2, kind of like so. This will go away and go away, go away, go away. So 15 over 4 is equal to x. So don't make the common mistake of finding the radius and saying, okay, this is my final answer for x, because the question wasn't asking for the radius, it was asking for x. Okay, so in this case, x is 15 over 4, and we are done. Okay, so hopefully you understood some of these questions. If there's something unclear, leave it in the comments. I'll respond to it. And yeah, so that's it. If this helped you, leave a like as it helps me. And yeah, that's it. So I hope you understood.